Good day, everyone. You are welcome to Galad Science Academy, and I'm here to continue the nuclear chemistry. In my previous class of nuclear chemistry, I've discussed the definition of nuclear chemistry as the aspect of the chemistry that deals with the study of the reaction that takes place in the nucleus of an atom. And the reaction that takes place in the nucleus of an atom, you can also call it what? Nuclear reaction. And the nuclear reaction comprises of 4 stages of, for example, we have radioactivity, we have radioactive decay, nuclear fission, and nuclear fusion. Now we have discussed that too. And the last one is what is kinetics of radioactivities, where we derive the formula for radioactive decay, half-life, the remaining decay constant, then radioactive what? Curve. So in today's class now, our interest is 2 things. It's mass defects and the burning energy. And as we all know that what? The nuclear chemistry, as we all know that what? The nuclear chemistry is the chemistry that deals with what? The study of what? Of nucleus of an atom. And like I said, that the atom is partially spherical in shape, and here we have what? The neutron, and we have proton here. We have what? Neutron, and this one is called what? Proton. Abi? So the combination of this proton and neutron is what we call what? Nucleus. This is the shell, or we can also call it what? Orbit. Is where the electron can be found in the what? In the atom. So this mass effect is the slightly difference between the what? The mass of an atom, the slightly difference between the what? The mass of what? Of an atom, and some of the what? The sum of the mass of the what? Of neutron, and the what? And the proton of what? Of an atom. So that is what we call the what? Mass what? Mass effect. Okay, let's go now. Let me call mass what? Effect. Mass effect are slightly different between the mass of an atom, and some of the masses of its component particle. Component particle, what has it? It's proton, it's what? Proton and neutron in isolated and combined form. That is what? The mass definition for mass what? Mass defects. is the slightly difference between the what the real mass of an atom and some of the what component particle, which is what proton and neutron, called mass effect. And this mass effect is also called, or it's also used or required. It's also required for calculating binding energy. So you can use mass effect to calculate what? Binding what? Energy. So mathematically, what is the formula for mass effect? Mathematically, so the mass effect, this is a symbol for mass what? Defect. This is a symbol. So the mass defect M will be equal to sum of the number of mass of proton plus number of mass of neutron minus real nuclear mass minus real what? Nuclear what? Nuclear mass. This is the formula for what? For mass effect. You can also write it in this form. This Z M plus N M N minus the real nuclear mass. You call it what? Capital letter what? M. So if you are asked to find the what? The mass defects, can apply this what? This formula. So, and the next thing that we are going to treat now is what? Is binding what? Energy. So what is binding energy? In energy. See, look at the binding energy. The binding energy is the energy equivalent to the mass what? Effect. Or is the energy that is holds or separates the particle of the what? Of the nucleus. You can say what? Binding energy. This is the what? Defined as the energy that holds or separates the particle of nucleus and it is energy is what? Energy equivalent to mass effect. And mathematically, the binding energy, it can be expressed mathematically by Einstein mass energy equation. This is the symbol for binding energy. Change in what? E is equal to the what? Mass defect C square. You can call this what? Equation what? Equation 1. Where change in E is the binding energy, change in M is mass defect, C is speed of what? Of light, which is 8 times 10 raised to the power what? 3 times 10 raised to the power 8 meter per seconds. And we can also say what? Where change in M is total number of mass of proton plus total number of mass of neutron, mass of what? Of neutron minus real nuclear mass, which is what? M. So this is what? This mass defect is this. If you can put it here, you have the binding energy should be what? Mp plus NMN minus M. Everything into what? C square. So this is also the second formula of calculating what? Binding what? Energy, which is equation what? Equation 2. From this, this is what? Equation what? Equation 2. This Z means number of proton times mass of proton. This N, number of neutron times mass of neutron added together minus real nuclear mass of that atom multiplied by C square, where C square is what? C square is speed of what? Of light. We can also express the what? The binding energy in terms of what? Univy atomic mass unit. So in terms of that, we have what? Change in E equal to the what? Total number of mass of number of proton, mass of proton plus total number of neutron, mass of neutron minus mass, the real atomic mass of the what? Of the atom. So everything multiplied by what? Univy atomic mass unit. So this is also what? Another way of what? Of expressing binding energy. You can call this equation what? 3. Or the last way of expressing it, change in N equal to the what? The total number of mass number of proton plus number of what? Mass number of neutron minus this. So everything over what? MEV. So this is what? The fourth way of expressing binding what? Energy. Where what? Where this Z is what? Total number of proton. This MP is mass of what? Of proton. N is total number of neutron. Mn is mass of neutron. Here, C, this C is what? Speed. No? This M is what? Real nuclear mass number. Real nuclear what? Mass what? Number. So the C here is speed of light, which is what? 3 times 10 raised to power 8 meter per second. And this U, A, M, U is universe atomic mass unit. So that is what? The binding what? Energy. So the next one is what? Binding energy per nucleon. By what? Binding energy So what is binding energy per nucleon? The binding energy per nucleon, this is the ratio. This is the what? Ratio of binding energy of nucleus to the nucleon. The ratio of binding energy of nucleus to the nucleon. What is nucleon? Nucleon is the total number of proton and what? And neutron. So mathematically, the binding energy per nucleon will be what? Energy per nucleon will be what? Binding energy over no what? Nucleon, which is what? Total number of what? Of proton and what? And neutron. So this is the formula for mass defects. This 1, 2, 3, 4 for what? Binding energy. But this one is for binding energy per what? Per nucleus. So it's remove one formula that I'm going to add. After that one formula, we are going to solve numerous problems. So the next one now is what? Is packing fraction. Packing what? Fraction. So this is the ratio between mass defect change in M And mass defect, change in M, and mass number. Mass what? Number. Uh-huh. Or new what? Nuclear number. Or we can also say the what? Packing fraction is the mass effect per nucleon. Or you can also say that what? Packing fraction, packing what? Fraction is mass defect per nucleon. So mathematically, packing fraction F should be equal to the what? Mass what? Defect over what? Over mass number. Or you can say what? Packing what? Fraction F can say is mass what? Defect over what? Nucleon. This, or you can also say what? Mass defect is this is a mass what? Defect over what? Mass what? Number or nucleon over what? Nucleon. It is what? The same thing. Finally, the fraction it will be what? This mass effect is what? Is isotopic mass minus the isotopic mass. We can also call it what? This, I will tell you add there, you can call it what? Atomic what? Mass minus real atomic what? Mass M, everything over what? Over nucleon multiplied by 10 raised to the power what? 4. This is what? Packing what? Fraction. So under mass defect and abundant energy, packing energy per nucleon, and the packing fraction, we have this. So let us look at how are you able to use all this formula to tackle physics problem.